All right, good afternoon, ladies and gentlemen. This is Tyler Newberry with the StorTrends team at AMI. Hope everyone is having a wonderful Wednesday thus far. We are looking forward to presenting to you in the next few minutes or so. For those of you who guys were in the pizza delivery zone, your pizza should be arriving in the next few minutes or so if it hasn't already. If it's more than 10, 15 minutes late, feel free to shoot me an email at tylerin@ami.com. Again, that's Tyler, Tylerin @ami.com, and I'll send that out to you as well. I'm the guy who's been communicating with you about the pizzas. A couple of quick housekeeping items, one of which was the pizza. The other one is that we do have technical difficulties from time to time on these presentations. We ask that if you do experience any, just to please bear with us as best you can and stay logged into the account. And if we do go down for some reason due to WebEx or something like that, we'll do our best to get back up within as little time as possible. Other than that, if you have any questions throughout the presentation, again, feel free to email those to me. You're more than welcome to send over questions and answers on the chat or the Q&A of WebEx. However, we usually do get a lot of those flooded in, and I can actually address your questions more individually if you were willing to send it over to me via the email. Again, that's Tylerin, Tylerin as in November, @ami.com. We have our engineer presenting with us today, Mr. James Dykowski. He'll be with us in just a second. But like I said, we'll try to get to all of your questions and answers during the presentation. If for whatever reason we're not able to get all those questions, we will shoot you an email sometime this afternoon with our best answer attached to those. So yeah, if you have any questions, feel free to send them on over. With that, I'm going to go ahead and introduce our engineer and main presenter for today, Mr. James Dykowski.
All right. So we had a little slide here, so if you guys ever need to reach any of us or anything like that, feel free to note it down and say hi, or obviously there's Tyler's email if you have anything for when it comes to like questions and stuff like that. So yeah, so we will get going here. So American Megatrends, so I'm sure a lot of you have heard of us, just probably not from the storage side of things. Obviously, we're a newer player, at least for the main competition in storage, the regular vendors there. And so anyway, so we have a long-term history within technology overall, obviously starting with the BIOS and, kind of working our way up through there of doing remote access controllers, doing OEM stuff with, Dell, IBM, everybody in that regard. And so we have a lot of worldwide offices, and in some way or somehow we're in more than half of the computers in the world today. So, so we are very, very much vetted technology-wise, but then also when it comes to storage, we actually started out the MegaRAID controller card that was actually purchased by LSI almost 15 years ago. So we sold that up, brought that team back in to American Megatrends, and we actually developed a StorTrends product line for basically going into SAN devices. There are a lot of patents around our technology. This isn't some ZFS, stolen thing that we're just kind of putting a little wrapper around and going out from there. And then we have a lot of installations in a bunch of different verticals and also different kind of workload types and stuff like that. So, so that's who we are. If you do have any questions, again, reach out, and we'll kind of dig in here so where are we at when it comes to the overall environment? How do we fit in? And here you can see the spinning disk environment on the left side. This is a very normal environment, and actually before this all flash craze, all this SSD stuff coming out, we had the same limitations. It's spinning drives, right? You have a certain amount of capacity, and you can only get so many IOPS out of these drives, and actually latency also in that. So here you can see on the left side, we have 5 enclosures basically in some rack to get a usable capacity about 40 terabytes. And then depending on your disk drives, we kind of split in the middle here just to be nice, but the latency is about 10 milliseconds. As long as it's scoped for a project that's exactly around about 13,000, 14,000 IOPS. And then you can see here rack space. You know, you're looking at 15U worth of rack space. All of these all these enclosures have dual power supplies. All these discs, they create heat. They use a lot of power, stuff like that. So there are emissions and all that kind of stuff. And of course, it's just a bulk of management and overhead. And again, I mean, you know, not to nick on whose picture here, if you guys know who it is or not, you know, we had the same limitations there with spinning drives and stuff. So we did try to build a better mousetrap around SSDs and try to leverage, you know, obviously just what's good about each individual drive type and take advantage of that. And of course, because we're looking at so many less enclosures, so many less disks overall, of course the SSDs are more expensive, but you can see here with deduping compression, so that's what we're basically talking about today, we can get a low raw capacity up to a higher usable capacity that's very similar to what we'll see in the legacy environments, but we get a way better latency, sub 1 millisecond, and that's at a spec of 100,000 IOPS. A lot less rack space, therefore less power, less drives, everything. So a lot easier to manage, and of course, you can get about half the cost. If you do $1 per gig and stuff like that, you can kind of see just how that meshes together. And so now, you know, some people ask me, well, you know, what's the difference between this? Why should I buy this instead of a, you know, just server-side cache or something like that? And of course, even with the legacy deployments of storage, everything has its fit, everything has its way. There's a reason, I mean, people aren't just, you know, starving trying to sell whatever out there. So you can see here with the server-side cache, it's a very different argument technology-wise, but you can kind of see here, so we scope about 10% of your usable capacity for basically server-side cache. Obviously, there's no extra rack space, there's no extra power hardly, I mean, whatever. And what you can see, though, is the latency. So for reads, just heavy online analytical processing, you're looking at about 400 microseconds. Now, this is pending the data going into cache. However, it'll get there, and you'll basically get 400 microseconds worth of performance in general. Now, online transaction processing, you're not going to quite see that same correlation there, and that's because, and this definitely depends on the configuration stuff, but you can actually see, you know, if you're writing to one server, you actually have to mirror this data somewhere else. So they end up, instead of like a storage array to where we can actually mirror the data within the array, they have to mirror it to another server and stuff like that. So there is definitely an additional overhead with doing all this stuff. Plus that other server is doing stuff too. It's cache drives. So there is a huge overhead in that regard. And then of course if you kind of mix this up, 50-50 average, 67-33 mix, you know, you can kind of see where you'd be at latency-wise. And, you know, if you look at your $1 per gig value, you know, it's about, you know, $6 per gig, something like that. Just looking at maybe like a 40 terabyte environment, kind of like what we're using for this example. And then, of course, on the other side, you know, the latency is very easily correlating to, you know, you're looking at maybe 3 milliseconds for writes, but sub 1 millisecond for all reads. And then so basically if you mesh that in any of these mixes, you're easily under the worst or the easiest case scenario for a mixed workload of server-side cache. But obviously, if it's all reads, I mean, you know, there is a huge value there. And even if they pick and choose which reads they are, instead of worrying about writes, letting the underlying storage vendor do writes, you can kind of mix things up in that regard too. We absolutely have deployments to where we are the underlying storage to some server-side cache, kind of mitigating I/O at the server level. So just larger deployments, people with bigger budgets and stuff like that. Everybody's different. And then, of course, so now, you know, we also have the hybrid. So we're talking about all flash, and we have our read and writes here with dedupe. Now, going into, you know, well, what has everybody else been kind of doing as well? And then we released this hybrid array about 1.5 years ago, and it's done very well, actually. So you can see here, you know, you get 45 terabytes user capacity. The guaranteed latency there is 3 milliseconds, and that's just because of tiering, having to kind of do what it is. But quite honestly, this ends up being very, very similar, basically 1.5 millisecond, and a lot of cases sub 1 millisecond worth of latency, especially on writes, though, for this, because we don't have to dedupe and compress any data. So there's a huge value in not having to do that. and the way that our algorithm works, we're actually writing all data to SSDs. And that's basically as effective as you can really get with a hybrid array, as writes are the main component for a huge latency number anyways. There are customers that we have with higher latency numbers that are full of reads, but it's a lot of reads. So anyways, you can kind of see the argument here. A very similar cost. It's just kind of what you need to be looking at. And then this usually does kind of scale out for absolutely larger deployments when you have 90 terabytes and 100 terabytes to get that up and stuff like that. So you can kind of see how that correlates here and all that. So now when they compare together, you can kind of see, you know, some of the problems with dedupe and compression, and we do try to solve this, and we'll talk about that, is, you know, well, what happens if you don't get a good dedupe rate or compression rate, right? We support dedupe compression. And literally, so dedupe, you can only dedupe so much in the environment. It's not like the whole environment is deduped, quite honestly. There's actually hot data that's not just us. This is how everybody works with dedupe. But there's hot data that you're kind of effectively watching. And so then, and in general, your most like data, so your dedupable data, is going to be more recent in that regard. So logically it works out as well. But say you don't get, you know, a 3.5, a 4-to-1 ratio, which is, you know, that's a pretty normal scope, but, you know, people do not always get there. And then, of course, heavy VDIs and stuff like that obviously get better ratios as well. But, you know, so you're looking at 40 terabytes. Well, now, you know, we scope the same system, but you only get a 1.8 to 1. Well, now you're down to 23 terabytes. Now your dollar per gig raises. Obviously, the cost is the same. However, you know, we have a more predictable environment with the hybrid array. So you can actually see kind of how these mesh well and just where the positives and negatives are. We have both of the options. We want to give you what works best for you, you know, and these are the facts, basically. These are what we've actually seen from customers, and, you know, it's just kind of how it works out.
Hey, James, we actually had a really good question come in just a couple minutes ago. Kind of piggybacks a little bit off of what you were saying, but they were asking, can you have different tiers of storage in one enclosure and write to different tiers based on your IOPS needs?
Absolutely, absolutely. So we have quite a few notes there. I'll probably talk a little more about it here going forward, but also, I mean, just obviously email me if you have a question, but absolutely, we're dividing these up into tiers within the same enclosure. So in a hybrid array, it is literally SSDs basically inside of this unit, and then spinning disks inside of this unit as well, be it 15K SAS or nearline SAS, whatever, and then different RAID types. So we tier based on RAID, disk type, and stuff like that. And then we also have policies based on I/O to say what goes where. So we can kind of see that, and I'll actually, I can actually show that in the demo here in a little bit. So why isn't everybody doing an all-flash array? Price of SSDs, obviously they're expensive, especially if you look at dollar per gig in comparison to fat drives, but 15K drive is really your performance drive, which is still a huge difference cost-wise. And then, of course, the SSD endurance is a huge factor of we don't know how long that'll last, right? So you obviously have to monitor that and understand how endurance works with basically different drive types and stuff like that and all that, and make sure you manage that. And then there's the dedupe capacity expectations like we talked about before. It's absolutely an X factor. Not even some VDI deployments, if you have a lot of different types of images and stuff like that, you know, this doesn't dedupe as well as others. So there's a lot of factors there, and then also the performance degradation with dedupe and compression. It's absolutely there. Our hybrid array will absolutely blow away our all-flash array if you just focus on hot data. Obviously, we're scoping on hot data in that regard for the hybrid array. And we're managing where the writes go and stuff like that, actually in both cases, but that's a side note. But anyways, by managing that stuff, we can actually make sure that all the hot data ends up in your hybrid SSDs and stuff like that. So it's just, you know, kind of one way or the other in that regard. So what everybody normally talks about, and even what I talked about last year and stuff, was really a focus around IOPS. And it's an important thing. And what it really is, though, it's more of a scoping mechanism of a target. But once you pass that, you have to worry about latency. So, obviously the different drive types, and I actually, I thought it was ridiculous that I put this 500 disks in here for 100,000 IOPS. Ran into a customer, we'll just say in the Midwest, that actually they had, it was 520-something disks in a competitor's array that they were actually striping up to get 100,000 IOPS, and that was their target I/O load. So it's actually, as ridiculous as it looks, it's actually a conceivable piece there. But anyways, you can do all this stuff with 4 drives to get this target workload and kind of work that way. So obviously, if we can look at latency now, so even at that target 100,000 IOPS with the 200 or 500 7.2K RPM drives, you're still going to be looking at a peak latency at that target of 15 milliseconds. So now what happens if you have 1,000 drives, right? That might be your question. Well, if you have 1,000, your latency is still not going to go down by half, though, just because you double the drives. Latency doesn't work that way. It's definitely logarithmic. So, so you'd be around like 10 to 12 milliseconds and stuff like that by doubling the drives. And you'll never exceed the threshold of about 8 milliseconds with 7.2K RPM drives. And then that goes down to 5 milliseconds with the 10K. It's about 7 or so of the 10K, and then 5 or so of the 15K. And then, of course, the SSDs, they just naturally are just super fast, so done. Latency, you just don't have to worry about it, even at that higher I/O load. So obviously, that's where the advantage is with SSDs, and this is just no matter what you do with it. If you're looking at, an all-flash array or hybrid or what have you, the SSDs, they do what they do. So here you can see, so now we talk about these numbers. So what does the latency mean? In general, nobody's down in this black hole. It's random peaks. Maybe a drive failed and something crazy happened. And so this 800 milliseconds is kind of the black hole. Just anything beyond that, I mean, forget about it. This is, where VMFS will start timing out, stuff like that in VMware. And really, you just end up kind of locking down the solution because of these kind of issues and stuff like that. Most everybody, if you're sustaining and you're okay with performance, you're in this blue box right here, the 5 to 20 milliseconds, maybe a 20, 25 at peak, but then, naturally kind of in between a 5 to 10, just depending on what the kind of workloads are and stuff like that. But, everybody wants to start getting this, hey, look, we got these SSDs, everybody's investing in technology. Now that we've kind of broken out of the lull that we've had over the last few years. And so now you want to get this, okay, let's get this thing fast, let's get this thing snappy. And actually the snappy comes from one of our customers that last year, he was talking to me about expanding, hey, I want to get another expansion shelf. But he was overloading what he had already, and he was like, so do you think that'll get our, our latency down, by half, or in this case, he already had 2 shelves, so it would have been a third, basically, is what he was asking. And I was like, no, I mean, it's not going to do that because it doesn't work linearly like that. So, so then he was like, okay, what do we got to do to make this thing snappy? So we got him actually it was an all-flash head with a JBOD, basically making a big hybrid array, and it is snappy now. So everybody's happy. Okay, so SSDs, so one of the other issues is space. You're limited on capacity, and even worse, your dollar per gig capacity is horrible. So here we go. We have deduping compression, and then in general, this is just a chart kind of saying, well, in general in the world, where do we expect data to kind of go? And these numbers were from Permabit. Published, I don't know, a year ago or something like that. So you can kind of see where the charts, I guess it's a little over halfway at about a year ago, but how they expect it to grow and what you're looking at this exponential rate here, and then how much of this data is duplicate. Even for the example of just more and more people, they're just taking pictures. Of course, Apple is now the largest photo provider, creator, what have you, in the world now. Now, of course, a lot of these photos go to iCloud. Now, who knows how many copies they have of all this stuff and all that. So, anyways, you can kind of see where this duplicate data would come in. and all that stuff. So conceptually, it's very easy, and just new data gets created every day. So going into the technology, so the overall idea is just to reduce overall I/O. One thing that we do with our dedupe and compression in our all-flash array is basically watch all the blocks and make sure there's no duplicates, right? So on the right side, you can see the picture here. You can see multiple red files deduping into one file on the right side. Well, for each colored file, and you can see one's kind of a PowerPoint, one's an Excel, one's like a Word, a lot of crazy graphics going on here. But anyways, this is a 2-to-1 ratio, so you have 2 files to 1, you know, just to kind of knock this down to a base level of understanding of where this ratio comes in. So if you do have 2 terabytes worth of file space, that will now be 1 terabyte with dedupe only. Now with compression involved, you will get a further reduction, and it depends on the basically the data type and stuff like that. But the huge note on all that is, especially with files and stuff like that, they're already compressed data by, at least 99% of everybody uses PowerPoint, Excel, and all that stuff. Well, in that, they've already compressed this data, so it's actually less likely to get deduped and compressed because of that case, because it is harder to dedupe and obviously compress already compressed data. So that's why sometimes you get these just worse values in that regard. Did you have a question?
Yeah, let me just jump in right here because we have a couple of good questions that kind of relate to this. So don't want to get too far away from this discussion before we answer these questions. But and this might kind of go into what you're talking about next, James. But as far as SQL is concerned, SQL's out there in almost everybody's environment. They're using it. What would you think the approximate dedupe ratio for a SQL database would be?
I'm on it on the next slide.
Perfect.
Yep.
So we'll get to that.
Yep.
And what rate level would you say this performs best at?
So obviously RAID 10 is the fastest for writes. If you have, say, the same disk count, obviously you're going to get the same reads from all the drives as you would a RAID 5, at least with the distributed parity RAID 5, which is standard. Not everybody does like a RAID 4 or RAID DP or something like that, like what NetApp does, to where they have a dedicated parity, so you don't get that performance out of those drives. So it's really looking at writes. And then really the only time, though, that I would scope a RAID 10 is if I was really heavily worried about how much I/O a customer had, and basically they needed a heavy write load going to it. So in general, RAID 5 is the easiest thing. RAID 6 is also there if somebody was nervous about drive failures. That being said, these are very predictable when it comes to drive failures. SSDs, we can watch the endurance and we can say this thing's at 50% endurance. The cells are wearing down at a certain threshold. So once they get down to 20%, we actually go ahead and replace drives and stuff like that ahead of time. So we don't worry about abrupt failures in that regard. As obviously hard drives, spinning drives, there's a lot of mechanical errors that can happen inside of them. To where basically we have to worry about that. So anyways, RAID 5 is just the general consensus for SSDs.
Okay, certainly makes sense there. And, you know, we were talking about like the IOPS we can expect a little bit earlier if we were to use, you know, as 4 SSDs or something like that. But what is the absolute maximum capacity that we could get with 4 SSDs?
Yeah, it just depends on the underlying size of the SSD. So our largest SSD that we support right now are 2 terabyte drives. I know 4 terabytes are actually getting validated or something within the lab. So with 2 terabyte drives, you know, we'll just say that you got a RAID 5 in that, just to kind of try to make space as efficient as possible. So you have 6 terabytes there, and then basically multiply that by a 4-to-1 ratio. We'd be looking at, for a standard scope of, you know, 24 terabytes for a customer. In general, with an all-flash array, obviously we're going above and beyond that capacity-wise because we're able to leverage a lot more SSDs in that. That was just kind of to put the target of 100,000 IOPS in perspective, I guess. Obviously, we have more SSDs there, so it kind of changes the, I know it's a weird argument, but otherwise I'd be saying, okay, we have 16 SSDs, well, they can get, you know, 400, 500,000 IOPS, whatever, and then basically I'd say, well, you need 1 million nearline SAS drives to get there. So
Sure. And last quick question, then I'll let you get back into your wonderful discussion here. But are there any disk fragmentation issues when you go all SSD, all flash?
Oh, interesting. I actually had a customer ask me about defragging their data. Was it last Friday? It was either last Friday or the Friday before. And I was doing a review of them. And so the way that we manage data, we're actually watching what is actually hot data and what's cold data. So we're actually fragging the data on our own level. So really defragging anything on the end user side would actually kind of mess up our data. It would make everything hot as it kind of realigns everything. And then basically it kind of pulls our algorithms out of whack actually. So anyways, we already kind of fragment it or defragment it in that argument just by making sure that, you know, the hot data is actually more accessible than the other data. We do it in a bunch of different ways. So.
Very cool. Well, we can kind of get back into some more of the questions a little bit later on, but thank you, James.
Sounds good, and that's absolutely no problem. So the performance increase here for dedupe and compression, basically if you do get a duplicate file, though, or duplicate blocks, basically we are looking at this block level, it just does not have to write to the disk, actually. So we'll actually do a test of it. It's inline dedupe. Everything's absolutely inline. We don't do anything post-process. So we always maintain performance as much as possible in that regard. So if it is a duplicate block, we don't even have to write it. It actually goes into RAM and done. It's acknowledged as written. If there's an endurance question or whatnot, obviously if you're not writing to the SSDs in all these cases, you're absolutely reducing endurance in that regard. We also do actually have a write tier with enterprise MLC drives and then a read tier with MLC drives, so we are actually watching endurance and kind of playing a game with that, and we'll talk about what we do technology-wise with that. And then effectively, you know, you can get a 3-to-1 ratio. Obviously, there just brings a lot of value in that part, as long as you can get a pretty good ratio there for that. So there's a huge cost savings with this technology. And then looking at these numbers here, so we have this slide. We talk about 40 terabytes, just say each of these are 10 terabytes each. So we have 50 terabytes now or something. So when we have these different types of setups, you have backup, you have VMs or VDI, you have databases, huge note with workflow there, and Exchange and user directories, so you can kind of see where this lands. So if we just had compression, which somebody like Nimble only has compression, here's kind of where your values end up in that regard. Now, if you only had deduplication, here's where these values would end up in these scenarios. Now, by combining the two together, you can see that we're just absolutely making this as efficient as possible in this regard. So things like backups, obviously there's an all-flash array. That's kind of forward-thinking, but there is a lot of inherent backups. Even in our snapshots, we've actually found with the granularity of 4K here of our dedupe, that we're actually saving a lot of space from our snapshots even being taken, because there is a lot of duplicate data in there, because we are saving blocks, but maybe only a little bit was changed. VMs, VDI, so this 33-to-1, basically, and these are the best situations you're going to get in. So this VDI would be, you know, maybe 2 master images to where you're basing all your clones off of, and so there's heavy dedupe in that regard. And you can kind of see that with the chart here. Database environment, so a standard database environment is not going to get this, though. This with workflow is a huge note on everything. And what workflow implies, and it's pretty explicit, though, is so if your application does something like, say every user that logs into your database, that application basically spins off its own little database for that, for them to read off of, maybe update, and then they roll those changes into the main database once that user logs out. That would be something like workflow, or a situation to where you know, you have a reporting database or multiple reporting databases, which are just spin-offs of the regular database, maybe from the night before or something. And then also, you know, maybe there's multiple active databases for different uses and stuff like that. Well, that would be workflow, to where you have all these instant copies of the database active at all times. So that's where basically the space saving comes in. If it's just one database that you're holding for the customer and they just kind of use it, say it's just a standard CRM or something like that, you're not going to get this kind of savings. Exchange, so the standard situation with Exchange is a 9-to-1. So the standard situation of pre-2010 stuff was a non-compressed exchange environment to where you can have, say 10 terabytes, or we'll say 9 terabytes to make this easy. So you have this 9 terabytes, and absolutely throw that on our unit, and you will get 1 terabyte worth of used space on the SSDs. Now, the latest options with the latest exchange, the default is actually to have that compressed data. And they had it checkboxed by default and all that stuff. So what happened was we actually had a use case here to where they had about it was a 9 or 10 terabyte database, we'll just say 9, and what happened was Exchange actually knocked that down to 6. Okay, well that's pretty good. All right, good job compression. So then they threw that database, which was already compressed, onto our storage unit on an all-flash array with deduping compression, and that went down to 3 terabytes. And so they were like, well, we have 9 terabytes. That's only a 3-to-1 ratio. What happened? And so basically, or actually it's a 2-to-1 ratio for us because we saw 6 terabytes going down to 3. Well, in this case, basically, you can actually see that it's compressed data. It doesn't dedupe well. It doesn't compress well after the fact. So what we're doing is absolutely as efficient as possible. We uncompressed that data for Exchange and actually then re-threw it on the box, and it was actually 1 terabyte usable. So there was a huge note there, and there has to be a change of the way we do things to actually align towards actually the storage vendor doing deduping compression. And then user directories, see that 2-to-1 right there? That was a 6 terabyte compressed database by Microsoft. In Exchange, that went down to 3 terabytes. It's the same logic with user directories. 99% of everybody's using Excel, PowerPoint, all that stuff. It's already compressed data, and you will see a 2-to-1 ratio from that data. And there's absolutely nothing. I don't care what magical vendor you have or whatnot. You know, the blocks are only as dedupable as possible. So you can basically kind of see how these situations fit in. And this is also why we have not bailed on our hybrid storage array by any means, right? There's a lot of value in just knowing what you're getting and where you need to be. Did you have a question?
Yeah, we did. We actually had a couple of really good ones.
They can't all be good, Tyler.
Well, no, I'm skipping the bad ones.
Oh, okay.
Yeah,
okay.
Yeah. Definitely don't acknowledge those. Anyway, so this one I'm sure you're about to go into in a little bit, but it's will compression of data affect the performance? I think you've already touched on that a little bit, and there's probably more of that a little bit later in the presentation. So I know you'll get to that one. But how do you manage the SSD longevity? Does our software do that? And can you explain kind of the SSD garbage collection and all that good stuff?
Absolutely. So I'll actually we'll get to that in a second. And when it comes to compression, absolutely there's an overhead with performance, and that's actually why we actually reduce how much compression we do. So on the last screen, when you see, oops, got to go way back. When you see, we talk about the performance increase and the endurance increase here, and we're reducing what we're writing to the disks. Well, if we see that it's a duplicate block, we actually don't even worry about compressing it because there is an overhead with compressing it. And then these are all for writes. However, reads, you have to uncompress everything as well. So the same factor kind of applies in that regard. And then when it comes to
the SSD longevity and how we manage that?
Yeah, we'll talk about that. But yeah, we absolutely manage the SSD longevity and kind of make sure that we're writing to the enterprise drives versus the read ones. So we'll talk about that. So here you can see just a VDI application. This is just kind of a high-level scope here. And so the normal situation for a hybrid is you pick and choose where you want the volumes to be. We can pin volumes into certain levels and stuff like that. And then, of course, obviously the advantage with an all-flash array is it's one tier. We do have read and write, and we do kind of split that up, but it's one SSD tier anyways. And you do get performance from everything from each tier. Now, obviously, snapshots, golden images, you know, there's not a lot of duplication in that regard. So the replicas is where all actually the performance comes from, but there is a lot of duplication there. So you can kind of see, and then the user space is going to be very much like user directories, a 2-to-1 type ratio and stuff like that, which actually ends up being a very large bulk of your VDI data, so at least with persistent disks. So you can kind of see how that applies there. Databases, we do watch, and there's absolutely hot data in databases, so you can kind of see what we do with a hybrid array here. Well, of course, same logic, pin-specific workloads. Say you have a particular database of an F drive that really gets written to heavily, blah, 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 but then your other, E drive or whatnot, whatever you're splitting off, you can kind of split those into different tiers and stuff like that, depending on their workload. Obviously, there's a huge advantage in having everything in all SSD. With snapshots in particular, some customers of ours will take snapshots and actually mount them on a separate, just a kind of a temp database or a test database, and then run I/O to them. Well, they didn't want to have the performance degradation of basically that test. They wanted to have the same performance. So having those snapshots in Tier 2 was a little bit prohibitive in that regard. So basically now you can actually get that SSD performance even out of snapshots and stuff like that. And then one thing that we've had as our bread and butter for years before this SSD craze is replication, and basically just doing standard disk-based storage and then replicating that data. We do have this wide area data services, the WDS in the middle. This has WAN optimization in it, and this is not just increasing the TCP window or anything like that. We actually have a full-on UDP link there's actually a few patents around all this stuff, basically to make sure that this link is optimized. It's using every little bit of it. That's no pun intended bit. Just kidding, I'm stupid.
Nailed it.
Yeah. So anyways, it's actually using every bit of that link for replication if it has anything to send. And then, of course, we compress, dedupe the data, encrypt it if that's required as well. So, and we can also replicate the different unit types as well. So we can have just an all spinning disk thing at the DR site and have an all flash array at site A. So you can kind of mix and match, and you can also go many to one, one to many, what have you. Also, so a lot of options there.
I'm sorry, James. I just keep getting flooded with great questions. So I just got to hop in there real quick.
Okay.
So, obviously we're definitely are a big supporter of iSCSI, but we had a gentleman ask, how many ports we have on the enclosure and how many channels are available on the enclosure.
So you can have up to basically 6 ports per controller, so 12 total ports of 1 gig, and then you can have, so there's a standard of 2 1 gigs per controller no matter what. So on top of that, you can also have 8 total 10 gig ports. We do support active-active as well, so you can really get a lot of throughput out of that if required.
Very cool. And this next question kind of feeds, right into our wheelhouse. But the wide area data services that you were talking about earlier, is that an add-on license or appliance, or is it included in the cost of the array?
One thing beautiful about us is this is an all-inclusive array. Everything I talk about is included in the price of the array. There's no add-on license or anything like that. So say today you bought, say you did buy an all-flash array or whatnot today, and then maybe 6 months or a year from now you wanted to buy a spinning drive array just to kind of house your data, have the snapshots automatically replicate out. All that stuff's included. You don't have to upgrade a license or anything like that. Yeah, there's definitely some competitors that don't agree with that model. However, we just feel like it's just simple, and why not get everything in the product? We're selling a full-on product here, so yeah. Okay, so in this regard, so how does replication feed into tiering and stuff like that? Well, one thing great with the hybrid, so you can have your DR space, you can see that at the bottom, down into your spinning drives and stuff like that. And then, of course, say it's an active-active site. Say you're replicating from one hybrid to another and back, which we absolutely have customers doing that. So you can basically say, okay, my SQL and VDI, that takes up SSD space, but I don't want my DR space up there, so you can pin that data down. Obviously, upon failover, we can basically increase that up by profiling and allow that to have the SSD performance. Obviously, with the all-flash, if you did do a failover, you do have your DR space fully available in SSDs already, so you don't have to worry about that promotion kicking in. And we do use caching and tiering to make that a fast promotion. However, it does take time and stuff like that, and basically we'd have to wait for cache to kind of mitigate the I/O from the Tier 2 up front, but then eventually we'll have the tiering kick in and basically take care of it. So how do we know this stuff? We definitely had a lot of questions today, or I went on tangents with those questions. So we have an iData tool. This tells us all of our performance. Basically, you can kind of get an output file of IOPS, throughput, everything on the right side here, and a lot more. There's an overview page, and then there's also individual server pages, and then also if it's a VMware infrastructure, it'll go down by VM and kind of list out where your I/O is. In that regard, this is agentless when it comes to the individual servers. You just plug in the IPs, give it administrator credentials, and we'll actually pull those every 5 minutes from each server in there and basically log all these results. Then we get that file back, which is encrypted, protected, and it is only WMI performance counters or VMware performance counters. And then basically just ensure that, check everything out, make sure there's no bottlenecks, and run that report and basically give that out to you. We do also have a dedupe expectations iData. It's a separate installer because there is I/O overhead with actually running that one, to where we can actually say how good or bad your dedupe might be. So we can kind of know that up front. So again, just a centralized server, kind of that square box right there. You can kind of see how when it's running what it looks like. You can see I have an ESX host in there, Windows server in there. And you can kind of just pick Exchange, SQL, VMware, what have you. Another side note was the Windows 8 logo right there you can kind of see. We actually use it for VM profiling for VDIs and stuff like that as well, or user profile, I'm sorry, and stuff like that. So kind of an after-the-fact note that came in there is a huge advantage. And then if you guys want to download it, just resources, you can see the dedupe analyzer tool right there, and then the iData tool second from the bottom. Click on there, click download, and you're good to go.
Yeah, James, this must just be a world record day for great questions.
Okay.
I'm kind of hop right in here. This one kind of piggyback off the iData tool, but yeah, just real quick clarification. Does the iData service, does it only work for the drives that you host, or does it work for the entire network, wide device monitoring?
Yeah, so it's just looking at SAN and direct attached devices for any of these servers and or hosts. So basically it doesn't have to be StorTrends or anything like that. Obviously, we're using this to make sure that we put in the correct amount of all flash space or a hybrid space, basically SSD space and stuff like that, to ensure that we know kind of what hot data is.
And we had another great question leading to another very popular StorTrends feature. But it's, do you have to have, if you're doing disaster recovery, I'm just going to paraphrase a little bit here, but if you're doing disaster recovery, do you have to have the same unit in both locations? Meaning, if you have a hybrid array or all-flash array in one location, do you have to match that in the other location, or can you go something cheaper?
You can do something cheaper. So you can have an all-flash array at site A and then just a spinning drive array at site B. No big deal at all. Yeah, you can kind of mix and match. All of our StorTrends arrays talk to each other. And because we have basically everything from spinning drives to a hybrid to an all-flash, we can kind of manage that in that regard. So yeah, they can all talk to each other. So you're good? Okay. So iData. So what it gives us is actually how much hot data you have. And these are actual customers. On NDA, I'll actually show you who they are and everything, what have you. But you can actually see, how much cold data is in here. So this data is absolutely unaccessed within a week. It might be accessed, maybe there's actually just a little bit that's accessed within a month or whatnot. And this scale obviously just kind of trickles down for 2 months or 3 months and stuff like that. But you can kind of see how much cold data there is overall and how much actual hot data there is. So there's 100 it's not IOPS really, it's 100 accesses within an hour, so IOPS with an H. And so basically you can kind of see how much data is really hot, and really you definitely don't exceed past 3%, 4% here. So this is where, you can kind of see how much SSD space do you really need, and this is where a lot of hybrids fit in because you don't need 10% or 20% of your SSD space in SSD. You can actually get more efficient than that. And a lot of vendors, I don't know if they don't know this stuff or what have you, but anyways, you can actually get away with a lot less. In this case, though, you can see even within an hour, we don't know how much of this data was hotter the previous hour and stuff like that. But you can kind of see, 10% actually is a good number if you just want to play it safe and stuff like that. So, and this is for infrastructure customers, so they have everything, some file share, some this, that, Exchange and stuff like that. To where some customers are actual just straight database customers, All they run are their databases. This is the lifeline of their company. In general, this is probably what they use for their customers and stuff like that. And here you can see it's actually a lot leaner. You actually use less than 2% in all scenarios, and that's 100 plus accesses within an hour. Quite honestly, 100 accesses is nothing if you look at it in an IOPS situation, right? So it's even lower percentage in that regard. So, and these are all absolutely different customers, absolutely different situations, and you can kind of see a correlation in that regard. So if we kind of mesh these together, just to get a generalization of everybody together, you know, you can kind of say, okay, you know, say we have, you know, 8%, something like that, you know, and you have a 40 terabyte environment, you're looking at about like 3 terabytes worth of usable space just to cover the hour. Well, I mean, that's a lot of money. If you're looking at 30%, you know, you can see the 12 terabytes there. If you wanted that in SSD, well, that's absolutely very expensive. So with that, we can kind of manage all this I/O with watching how much read and write data you have. So we have this read tier, write tier. Write tier is just simply enterprise MLC drives. What do? We make sure all writes go to the write tier because those enterprise drives can handle 87 petabytes worth of writes over a 5-year period. Very easy. When you look at how much data that is, that's 10 drive writes over within a year, or within a day, every day. So I can see there's a little bit of a lag here with the charting. I'm hoping that you guys will catch up. Of course, this is one of those technology deals. And we have a little bit of a freeze here, it looks like, stuck on the hot data slide.
All right, everyone. Looks like we might have a little bit of a lag as far as the visuals are concerned. Just please bear with us as we try to, you know, kind of get through this. You know, refresh the page if you need to. You may need to log out, log back in real quick. But yeah, again, really do apologize for that. This does happen every now and then. But yeah, so it looks like we are back up and running a little bit better now. We are still having a little bit of lag time. So yeah, just please bear with us. But we can hear the audio as well.
We'll kind of go forward here. Yeah, I'm connected. Okay, well, I'm fully connected here. So what we're doing is, oh, there, it finally caught up there. So you can see the read and write optimized here. So we are making sure that writes go to that write tier. These are the enterprise drives. Now the read tier is absolutely the opposite. They cannot handle the endurance of basically all the I/O load that would normally come in. And if anybody says differently, well, I promise you they can only have a fifth of their basically capacity written to every day for 5 years straight. So if you are writing less than that, then maybe that is a good fit. But we are actually looking at everybody's data. We know how these writes come in and how much I/O this is. So we are kind of managing this stuff. And then, so what happens if you have this Z block written to? That's probably the biggest issue ever. It turns into write data all of a sudden. Well, what we'll use is actually our NLIFT cache to basically make sure that that data goes straight into the cache, into the write tier, and make sure that we mitigate the performance, or the endurance, I mean, of basically the I/O that's coming in for the SSD. So you can make sure that this lifespan is absolutely increased tremendously for everything. And then even better, the read tier, these drives are 75% of the performance of the write tier drives, which is still fast. But the bonus is, if we do have heavy reads, they will, A, come from the read tier, but B, it'll actually be even faster than the write tier, because there's actually almost double, well, there's always double or more of the read tier drives individually. So double the drives but 75% of the performance ends up being a lot faster. So, and that absolutely works out when it comes to actuality of I/O. That's not just a theoretical value there. Storage support, we have everything that's basically required in support. We have a local presence to where you talk to the same guys all the time. This is housed here in Atlanta, Georgia. That's where Tyler and I are right now. So we don't ship this off overseas or anything like that. They may have a little southern accent, but that might be the craziest discussion that you'll have. Next business day standard. We do remote email alert monitoring, so we are aware when anything critical happens to the array, disks, controllers, whatnot, fans. And ahead of time, we watch medium errors, we watch the endurance, and we actually replace drives before they fail. When it comes to hard drives, 9 out of 10 drives we end up replacing ahead of time. And then when it comes to SSDs, basically it's endurance, it's 100% accuracy. We haven't had a live failure in that regard, so we don't have to worry about that kind of stuff. And I know we talked about the different types of units and stuff like that. Well, basically you can kind of see how these models are. And basically the 3400 is just all spinning drives. 3500 is a hybrid array, so it has a little bit of SSDs, a little bit of spinning, but it's great for huge capacities. And then 3600, as long as you can get a dedupe out of it, basically it's a very good use for you. And then here you can kind of see the difference between the two. Basically we just kind of manage and say, okay, you know, here's the right tier, read tier, and we try to use the 3600 just for 64 terabyte customers as a max capacity, so we don't kind of wear them out and stuff like that on just giving them too much CPU and memory when you don't need all that, you know, when you're looking at 20 terabytes and maybe 30 terabytes down the road. So we've done a lot of reviews performance-wise. We'd have to really talk about that in depth if you guys had any questions, but a lot of just validation performance-wise, and then the SSG now actually checks that iData report like I talked about that's encrypted and only WMI counter. So we did a little bit of due diligence there. Here you can kind of see the latest charts from StorageReview.com, pitting us up against a lot of our competitors. And transactions per second at 30,000 users, you can see 6,200 users. 6,200 transactions per second, to where nobody's broken that 6,200 mark, first of all, and then even better, nobody's broken the 100 millisecond mark when it comes to the latency in that same test. And we're actually at 41 here, so we're at basically a third of where the next competitor is. So a lot of efficiency when it comes to what we're doing there. And here you can kind of see XIO did eke past us in this regard right here on the VM mark. However, they did have 2 more SSDs than we did. And you don't get a chance to redo this test. However, we're very happy with the results. And it just shows how efficient we are in general. Bunch of different verticals, bunch of different customers and types of customers and I/O loads and stuff like that. And, you know, one thing beautiful about this, probably 95% of these customers, I think it's 90 or 95% of these customers are absolutely customers of the last year, and then even better, 75% of them are repeat customers. So you can actually see, you know, there's a lot of validation in our technology and what we're providing to the customer in that regard. And here are just some, you know, samples you guys can kind of take a peek at. You know, Iconotes, you know, they wanted the snappy storage. They had a .hill SAN. You know, we had a replication, bidirectional replication at TGI in the bottom left. Aquatech, centralized storage, replaced the NetApp. You know, they're doing a little bit of VDI and stuff like that. And then UT Dallas, you can kind of see they were doing a full-on lab consolidation and wanted to get this thing more efficient, more reasonable. So just some examples for in that regard. So that sums us up for that right there.
Very cool. Let me just attack a couple of quick questions right here. I know we're finishing up in like the next 5-6 minutes or so. So yes, I'm going to go ahead and you know, knock these out the best that we can. Again, if we aren't able to get to your question, we will definitely reach out to you via email later on today with the answer to your question. However, one of the questions that we did have was, James, is the WDS replication, this might be kind of going over it again, but was it synchronous or asynchronous?
This is asynchronous replication. It's based around snapshotting. So We can go down to a granularity of 5 minutes. Obviously, we have a latency concern there, depending on how far away that is. But we can go down to 5 minutes and go up to whatever we want. We can have different retentions at different sites and all that kind of stuff. So, yeah.
Okay. We had a question kind of more about our integration with VMware. But as far as our VMware integration is concerned, are we able to proactively look at, VMware performance issues that I guess are more on their side, not so much the StorTrends side?
Yeah, so we report based on our latency and stuff like that once it starts crossing thresholds of things that we would see from the north side coming in basically to us. But specifically within VMware, there is a reason that you do have to look at their performance reporting versus ours, just because we'll see any I/O that comes into us and comes out. However, there's a full-on network that can cause issues and full-on server hosts with all kinds of other X factors of issues going on in that regard.
Okay, I'll take this next question. We had a question, is the 4-hour on-site response support, does that apply to our friends in Canada as well? And it does. Anywhere in the USA, North America, Canada, we can honor that 4-hour on-site in there. Very cool. And we've had a few questions about if you can have a copy of this presentation. The answer is yes, absolutely. We've been recording this presentation, and what we're going to do is in the next day or two, we're going to upload this to YouTube, and we can send out the link to everybody who attended today with the YouTube link attached to it, so you can view it again at your own leisure. Forward it on to colleagues or friends who might have missed the presentation, or other members of your team who might benefit from the information as well. Very cool. James, I know we probably want to squeeze in as much of the demo as we can in the next 4 minutes. So.
Yeah, well, I mean, I can kind of yap about any questions or whatever
okay.
As we kind of go. But, yeah, I'm just clicking around, basically showing different screens and stuff like that. So what's, like, the next question?
Next question is, like, how we integrate with other vendors such as, Equalogics or the, the EMCs of the world in our environments. I mean, I know we all know it's probably not possible for the two to talk to each other, but, I mean, do we have environments where there are multiple storage vendors in the environment?
Absolutely, absolutely. And really the only concerns there are when we do get into a situation to where there's a legacy Equalogic or something like that. Basically you have to worry about, in VMware you have to worry about things like the VAI primitives if the legacy array doesn't support it, but we do. So then basically enabling that for us, you can't necessarily do that while the legacy unit of whoever else is still going. So a few concerns in that regard. But
okay. And as far as like an SSD hot swap, let's say you have a drive that burns out or needs to be replaced at some point, what all takes place, as far as like what they can expect for like a RAID rebuild time and that sort of stuff?
Yeah, so RAID rebuild time. So we base that on workflow. We actually have this workflow management engine right here. I'll go ahead and click on it. So what this does is it'll watch your I/O load, and of course this thing's all over the place. The way I do I/O, I just kind of turn it on and off for demos and stuff like that. But you can kind of see it'll try this. Green is predictive foreground, so we'll actually manage the background functions based on how much I/O load is actually going on. In this case, you can kind of see that it's forced in a lot of cases because we just have to do it. But you can see here. To where it needs to do it, it'll do it in the off-peak hours and stuff like that. So we can actually mitigate, when we're doing anything in that regard.
Very cool. Well, I know, why don't you go ahead and wrap up, I guess, kind of the last couple of minutes, and any last-minute questions that we have, we'll try to get them in at the very, very end.
Yeah, just ping it in there.
Sure.
And then, so here you can kind of see the replication pair settings. We can change bandwidth utilization, throughout the day. You can add up a bunch of different levels here, and then have like default plans of 90%. Set, this is local right here, but I mean, just depending on what kind of pipe you have, we'll absolutely use every bit of it, even if it's 100 meg, 13 megabytes a second or something like that. But you can kind of change all your compression, encryption options, stuff like that. We can kind of see how much data is actually going across the wire here. Yeah, did you have a question?
No question. I mean, we got about a minute or two left here, so I want to go ahead and start wrapping up and be very cognizant of everyone's time, and thank everyone for coming up. But was there anything last minute
you wanted to thank them?
Thank them for coming, absolutely.
Oh, okay. Well, let's do that.
All right. Well, thanks, everybody, for coming. I know we've talked about a lot today, a lot of good information. Any questions that have come in recently, we'll address those. We'll shoot you an email with our best answer. If you'd like for a time to talk, we can schedule that as well. But, yeah, also on our website, if you're interested in looking at any of these units or these prices or anything, we do have a price quote generator. That's a hassle-free quote generator tool on our website. Basically, you just send us over the configuration that you're looking for, like how much capacity, what the support term is, performance requirements, all that good stuff, and we'll shoot you a quote within the next few business hours or so. So you can actually have a quote in your hand by the end of the day if you want one. The iData tool, also available on the website. But if you have any questions navigating the website or finding that information, feel free to shoot me an email. I'm always happy to help out any way that we can. James, do you have anything left for the nice people before we signed off?
Thank you very much for coming.
Yep. Sorry about those audio glitches. Hopefully next time will be better. And, yeah, we look forward to presenting to you guys next time. But other than that, this is StorTrends signing off. Thanks so much.